Welcome to Naresh Technologies. I'm Bangar Raju and this is part 2 of multi-threading. So in the last video, I've just been demonstrating you how a program executes by default. By default, every program is a single threaded model, and in a single threaded model, all the methods that are defined inside the program are executed one after the other. So right now, if at all you just remember the program or you watch it, so there I defined 3 methods in this, test 1 and test 2 as well as test 3. And these particular 3 methods are called from the main. And right now, there will be a thread which is going to run this particular code, and the thread is called main thread, and that main thread is going to call you the methods one after the other. First it will call you test 1, afterwards test 2, afterwards test 3. But what is the drawback in this approach I was telling? Whenever you just call the methods in a single threaded model, the one thread which is present in the program starts executing each and every method. First method executed, from there control goes to second method, from there control goes to third method. So in this process, if any method takes more than the usual time, if it is going to take more than the usual time, what happens? The next method which is present in the sequence has to wait until the thread finishes the work and comes back. So now to simulate this, what we have done here, we just been used a condition here. What is the condition? If I value is 50, we have just been made the thread to sleep by calling a sleep method. Sleep is a static method that is present in a thread class, which will make the thread to sleep for the specified time period in milliseconds. So let me execute this code once. Thread demo. If you execute, it will start with test 1. See now, after printing 50, it went to sleep, wakes up after 5 seconds, and then the rest of the job has been completed. Main thread woke up and then it has completed the rest of the job here. So like this it executes. So right now the 5 seconds, this method was not able to execute. Which method? Test 2. And this method was not able to execute, and no other method is also executing here. Unnecessary wastage of time. But if you can utilize this properly, if you can utilize this particular time, the wasted time now, and that time we can call this method now. But that did not happen. Why it did not happen? Because our program is single threaded, and in single threaded model, it executes one method after the other method. One by one, each method is going to be called for you in a sequence. Okay, fine. Now today let me demonstrate you how to use multi-threading in our code. So first understand what is this multi-threading. See, currently our program is single threaded. Because it is single threaded, what is happening? It is executing one method after the another method. And we have noticed it. If at all a method is taking more than the usual time, the next method was not able to execute. So we can overcome this problem by using multi-threading. So what happens in multi-threading is, in multi-threading, we can call each method by using a separate thread. So what is the advantage? What the advantage is, if at all we try to call each method by using a separate thread, operating system is going to allocate some time period for each thread to execute. So when operating system is going to allocate some time period, all the methods are going to execute with equal priority. What I mean to tell is, watch, I have 3 methods, test 1, test 2, test 3. These are the 3 methods. Right now, all these 3 are executed by using the main thread. There is a main thread, and this main thread started running the code one after the other. It is just going to execute the first method, and after completing the first method execution, it came to the second method, and after completing the execution of the second, it came to third method. So without that, what we can do is, we can create 3 separate threads for executing this code now. We can create 3 separate threads for executing this code. So like thread 1 to execute the first method, and thread 2 to execute the second method, and then thread 3 to execute the third method. Like this, we can just execute the 3 methods by using 3 separate threads. When you're going to execute the methods by using separate threads, what is going to happen here? What is going to happen here is operating system is going to allocate some time period for each thread. How much time it allocates is not in our control. So basically that is under the operating system control. Let us assume some 2 seconds of time has been given for thread 1 to execute. Okay. In these 2 seconds, how much work it can do, it will perform this task. And after that, the control will go to the second one. And now the second thread will execute for 2 seconds and just going to execute your test 2. So they're also same. How much work it can complete, it will do that. And from there the control comes to third thread, and within the 2 seconds how much work it can do, it will perform. Like this, again 2 seconds, 2 seconds, 2 seconds. Like this, the operating system is going to share the time between all the threads in execution. So just understand, all the 3 are not going to execute parallelly. I can better say it is a simultaneous execution, like thread 1 executes for some time, and afterwards control comes to thread 2 to execute test 2, and afterwards control comes to thread 3 to execute. Means all are given equal priority to execute. So in the meanwhile, suppose now thread 2 has to execute, thread 2 has to execute, okay, but unfortunately there is something wrong here and this was not able to run. Suppose there is a database operation and the database busy, not responding, so it was not able to execute. When it was not able to execute, the operating system will not wait the time here. Without waiting for that, it will go to the next thread and executes the next method. Again, see now, because thread 2 was not able to execute, the time is being shared between thread 1 and thread 3. Okay. After some time, thread 2 came into active. It became active. When it became active, again control goes to thread 2. It will go to control goes to thread 2, and again the process of the time sharing will work for us. So this is how it is going to execute. The basic ideology is utilization of the CPU resources to the maximum extent. And the second thing is, this works basically based on time sharing, and the time sharing is done by operating system. Operating system will share the time and they will execute for us. Let us watch this practically. Let's write a fresh program, thread test.cs, using system.threading. Next, class thread test. I'm just going to write this particular 3 methods as non-static methods, no issue, or otherwise static only, static void test1 for int I is equals to 1, I less than or equal to 100, I plus plus, console dot write line test1 plus I. So this is your first method. Second method, test2, and let's print test2 here, and then test3, and let's print test3 here. Yeah, this is the code I'm just implementing. Fine. So these are the 3 methods. Now I want to call these 3 methods by using 3 separate threads. Okay, fine. Static void main, and now here I'm going to create 3 thread instances now. Thread T1 is equals to new thread. Thread T1 is equals to new thread. Now you can pass a parameter for this. What is the parameter? The parameter is the method it has to execute. if you just notice, using T1 we want to call test1. So what you'll do now is you simply pass the method name as a parameter here, test1, and same like that, thread T2 is equals to new thread test2, and thread T3 is equals to new thread test3. And right now, if you just understand how many threads are present in the program is 4 threads. Why 4 threads? One is the main thread, and now these are the 3 child threads what we just have. So totally 4 threads, 3 new threads we created, and 1 main thread is also present for you in the program. And that main thread only is creating all these 3 threads. Okay, fine. Now let us see the execution process. Right now, because we are using threading, and watch it, we don't require to call the methods explicitly again. But if you compile and run, it's not going to execute. And you see there, thread test, it's not executing, nothing output. Why? The methods are not going to be executed. Do I require to call them explicitly? No need. What you require to do is, you require to start the thread T1 dot start. Because I said T1 dot start, watch it, only thread 1 will start here. Only thread 1 is executing. And it is only executing, no remaining 2 threads are not executing. Let us start T2 now. T2 dot start. When I call T2 dot start, thread 2 also starts executing. And now you can just understand what is time sharing. Watch. If you notice it, it is not only executing the test1 method, it is also executing the test2. Actually, test2 started the execution. Is it guarantee every time test2 will start the execution? Not at all. We don't know which one is going to start the execution. Sometimes test1 can start and sometimes test2 can start the execution. But here who started? Test2. And here time sharing process, the control went to test1. Again test2. Again test1. Like this, it is sharing the time between both the 2 threads now. You can see both the 2 threads are sharing, and here test2 completed the execution. Because test2 completed the execution, test1 only shared the complete resources and it was completing job. If you run another time, you may get a different output. If you run another time, you may get a different output. So it's not like, see right now, test1 started the execution and afterwards it was executing, and you can just see now also time sharing work. Earlier at 83 it has been completed, now it has been completed 86. So that's what, every time you will get a different output. See now, test1 finished the execution now. You can notice test1 started the execution and they are sharing the time equally, and who finished the execution now is test1, and afterwards test2 was utilizing the resource. And now let's start the third one also. T3 dot start. Let me recompile, execute. All the 3 threads are sharing the time now. All the 3 are sharing the time. See 3, 2, 1. See 1 did not start until here. And 1, 2 and 3 started first and executing. 1 started here. And now they started executing. All the 3 are utilizing the resources. Means equal importance is given for all the methods to run here. And test2 finished the execution, and here test1 finished, and finally test3. Even though test3 started first, here who finished the execution last is test3. So every time you will see a different output. You will not see the same output each and every time, because that is completely controlled by the operating system. Operating system will allocate some time period for each thread to execute. Okay, and we can call it as time sharing. And after that, all are utilizing the resource. Now I'll show one thing. In the previous example, test2, what we discussed, if a method is taking more time than they expected, the other methods in the execution are waiting. But here it won't happen. Why? If this method is taking more time to execute, only the thread which is going to call that method will stop there, and the other two threads will execute as it is. You can verify. We'll do it. What's it? Inside of this, let's write a small condition. What if I is equals to 50, console dot write line, thread 2 is going to sleep, and here I am writing now thread dot sleep. Next, console dot write line, thread 2 woke up. When it is going to sleep, at 50 it is going to sleep now, and after some time it is going to wake up again, and after that it will continue and perform the rest of the task. Now here you will have a doubt. What is this? We need to make a thread 2 to sleep. You directly called thread dot sleep but not T2 dot sleep. No need. Actually, the method sleep is a static method, and you cannot call it by using the instance. You should call it only by using the class name. Okay? And the important point to understand here is, who is calling test2? Thread 2. So because I have written thread dot sleep in the method, test2 method, inside the test2 method, thread 2 will go to sleep now. Thread 1, thread 3 will not have any impact. The impact is only on the thread 2 because this method is called by thread 2. Okay? Let us save it. Recompile the code. You can see here thread 2 went to sleep, and afterwards 1 and 3 completed the task. Okay, let's increase the time a bit more so that we can understand much more better. 15 seconds I am giving. And you notice that thread 2 went to sleep here, and now 3 and 1 have been finishing up their particular task. See, they completed their particular work. 3 finished here, 1 also finished. Now after 15 seconds, thread 2 will wake up and do the rest of the things. See, thread 2 woke up and completed the rest of its job. So we are not wasting that CPU time at all. We are not wasting the resources at all. What we are trying to utilize the resources to the maximum extent. So this will speed up the performance of our applications. So that is the advantage what you have in multi-threading. And here you just watch. After the for loop, in all these methods, I am going to add a line of code. What is it? Console dot write line. See, if this method finishes execution, thread 1 can exit now. Thread 1 can exit right now. Oh, here I am writing the code. What? Thread 1 is exiting. And at the same way, here also I am writing. What? Thread 2 is executing. And in the same way, here thread 3 is executing. And here I am writing thread main is exiting, because this method is executed by main. Execution starts from here, and the first thread is main, and main will call this method, and afterwards it will create these 3 threads and gives the control to the 3 threads. Come on, let us just watch it. Let's decrease of the time here because we understood the process. So let's decrease of the time. Let's run the code. Somewhere here thread 2 is going to sleep, thread 3 exiting, thread 1 executing, and thread 2 woke up, and thread 2 is exiting. Actually, we are not able to see that because the screen size has not been sufficient here. Before that only main thread exited. Okay, we'll do one thing. We'll just decrease this size. We'll go with 50. Thread test, and now you can watch this correctly. once the execution started, immediately main thread was coming out. Why is it coming out? Because this method is executed by main, and now main has created all the 3 threads and started them. And with this, the job of the main is completed and main thread is exiting from the program. So main thread exited, and afterwards one by one who complete their work will exit now. Here thread 3 is exiting. Why? Somewhere here 3 completed the work. Yeah, thread 3, test 350 finished, and 3 is exiting. And afterwards test 250 is going to sleep, and afterwards test 1 is performing the task 50, it exited. After 5 seconds thread 2 woke up and thread 2 is also exiting. So like this, one by one thread will be exiting from the program once they complete their particular task. So this is the process how you are going to call your methods by using separate threads. This is mechanism of calling multiple methods in a class by using separate threads. This will increase the performance of our applications because we are trying to utilize the resources to the maximum extent. Okay. Thank you for watching the video. For more videos, please subscribe to our YouTube channel, Naresh IT.